Let's build a logic circuit that subtracts the binary number b, being a 4-bit binary number, from another 4-bit binary number a. So this is the same as adding minus b to a. So suppose we want to determine 0101 minus 1110 according to this row of our truth table. Well, 0101 is 5 and 1110 is minus 2. So 5 minus negative 2 should give 7. So what we do is take the 2's complement of b. So flipping the bits gives the 1's complement, and adding 1 gives the 2's complement. So we have 1 plus 1 is 0, carry the 1, and 1 plus 0 is 1, and then we have 0, 0. And then if we add this to our number a, well, what we get is 1, 1, 1, 0, which is 7, as expected. Now let's go into our circuit in Tinkercad, and I've duplicated the circuit for calculating the 2's complement. So now we'll call this subtracting binary numbers. And if you haven't seen the video on how to build this circuit, I've provided the link in the description. So what we want is to add the 2's complement, which is the output from this circuit, of our binary number here, which we'll call b. So that will be minus b, and we're adding it to a. So we'll build another dip switch to do that. And let's just move that across to make some room. So we want to add a plus minus b. So we need another 4-bit adder. So let's copy this into here. And now we'll connect that to the positive rail and take the ground pin to the negative rail. And here we have the output from the complement of b. So let's just delete these outputs to these LEDs. And now we'll take the least significant bit of our binary number a into input 0a, and we'll color that in green. And this is going to be added to the complement of b. So the output bit 0 from the complement is going to go into the second input, being 0b. So what we have is a plus minus b. And this result is going to be output to our far right LED. And now we'll do the same for our next significant bit. So we have a going into input 1a of our adder, and negative b from bit 1 is going to go into our second input 1b. So we have a plus the complement of b, and then the result is going to go into the next LED. And then take our next wire in yellow. So from the next significant bit, we're going to take this as an input into the 4-bit adder. So that will be 2A. And the output from bit 2 is going to go into input 2B. So we have A plus minus B. And then we take output bit 2 to the next LED. And then finally, we take an orange wire from our most significant bit and that's going to go into input 3A. And then from output bit 3 of the complement, we take another wire into input 3B of our adder. So we have A plus minus B. And then the output from bit 3 is going to get taken into our next LED, which is this 4th one over here. And finally in grey, we're going to take the carry out from the full adder into this LED on the far left. And don't forget to connect the switches to the positive rail. So we need 5 volts going into those switches. And now we'll run our simulation. So as expected, 0, 0, 0, 0 minus 0, 0, 0, 0 should give all outputs of 0. And now we'll test the case that we did in the truth table. So we had 0, 1, 0, 1 minus 1, 1, 1, 0. So the output is 0, 0, 1, 1, 1. And let's record that in a truth table. So we had 0, 0, 1, 1, 1, which is 7 as expected. And now let's test this case over here. So 1, 1, 1, 1 minus 1, 1, 0, 1. So 1, 1, 1, 1 minus 1, 1, 0, 1. So that gives 1, 0, 0, 1, 0. So let's record that. So we had 1, 0, 0, 1, 0. So as we can see, 1, 1, 1, 1 is negative 1. And 1, 1, 1, 0 is negative 2. So minus 1 minus negative 2 gives plus 1, as expected. And note that the carry out is insignificant because there's only 4 bits that are being represented here, where the overflow bit gets dropped. But let's have a look at why we got this carry. So what we're doing is subtracting 1, 1, 0, 1 from 1, 1, 1, 1. So the first thing we do is take the complement. So first we flip the bits to get the 1's complement and add 1 to get the 2's complement. And finally, we add the 2's complement, as we mentioned, to our first 4-bit number. So that'll be 1111 plus 0011. And that's the same thing as subtracting the second number from the first. So 1 plus 1 is 2. And then 1 plus 1 plus 1 is 3. 1 plus 1 is 2. And 1 plus 1 is 2. So as we can see, we get a final carry that gets dropped. And I'll leave it for you to test some other cases until you're convinced that your circuit is working correctly.